Okay, so the ESP-IDF 6, released back in March. We are slightly behind. If you actually look at the GitHub repo and the releases tab, you can see that we're already on 6.0.1. So it's time to get with the program and get using the ESP-IDF v6. Now, there are a couple of things. If you're new to the ESP-IDF, then you need to get some prerequisites installed. So I'm on a Mac, so I need to run this brew install command. Now, if you don't know what brew is, you can go off to this homebrew link here. It's on the ESP-IDF website. I'll put a link to this in the description. If you're on Windows or Linux, there's other instructions, but make sure you get the prerequisites set up and installed. Now, I'm going to recommend using Visual Studio Code. There's a really nice IDE, and there's a nice plugin for the ESP-IDF. So let's go over to VS Code and get that set up. So we go over to VS Code, go here, here's the plugins and extensions, go here, and if you search for ESP, you'll find the ESP-IDF installation plugin. So let's install that, and then we should have this little icon appearing here, ESP-IDF Explorer. So click here, if you go to Advanced, and then you click the Open ESP-IDF Installation Manager. So it's going to ask us for where to download that application from. So you see here, EIM executable not found, choose a download mirror. Now, unless you're in China, just pick GitHub. If you are in China, pick the expressive one, it might be faster. So that's launched the ESP-IDF Installation Manager. So we're on a fresh install, so there's nothing installed at the moment. We'll just click New Installation. Now there's two options you can do, well there's four options, but two options that you should probably care about. There's the easy installation and the offline installation. Now, easy installation should work, but if you have problems, what you can do is an offline installation. And if you go to this website here, then you can download the offline files. Now, they are quite big, 3 to 4 gigabytes, but if you're on a dodgy internet connection and you can download these to an SD card or something, you might have better luck. But let's stick with the easy installation. So we'll do Start Easy Installation. And it can take between 10 to 45 minutes. It really depends on your internet connection. Now, while that's chugging along, let's do a quick shout out to PCBWay. So they produce these PCBs and this dev board that I'm using to test this out. They're really good. Check out a link to them in the description and get yourself some PCBs made up. It's great fun. So what's happening right now? So at the moment it's downloading the ESP-IDF. So it's cloning that from GitHub. Now this step can take a while, so we'll have to sit here for a bit and watch the spinning download button. Okay, so that's the first stage done. We're now pulling down all the tools. So tool 3 of 10, and you can see in the log it's doing a bunch of work. So it's got 39 seconds at the moment. This progress bar does tend to be a bit random. So you can see it's actually going up even though we're making progress. So we'll leave this chugging along. It should download the tools, and it's normally fairly quick, so 5 of 10. And again, this will depend on your internet connection. If you have a really fast internet connection, this will be happening very quickly. If you're on a slow internet connection, make yourself a cup of tea and sit back and relax. Okay, so we're almost done. It's done the last of the tools. We're on to the next stage, setting up Python. Hopefully this will be quite quick. There we go. On to configuring environment. 12 seconds left. Getting very exciting. I feel like we should have a drum roll. Although it does seem to be stuck on 12 seconds. Okay, we're done. So if we go to the dashboard, we've got installation complete. You can now see we have ESP-IDF v6.01. Now you can update this and do all sorts of stuff. Really handy. But let's get into VS Code and actually create a project. So we're back in Visual Studio Code. So what we can do now is we can do New Project Wizard. So there's a little plus thing here, New Project Wizard. It asks us which ESP-IDF version we want to use. So we've just installed 6.0.1, so I think we should use that. And now we can go to the examples. So let's have the Get Started examples, and we'll do the classic Blink sketch. So let's create a project using the Blink template. So I call it Blink. Let's call it Blinky1 because I might have several Blinkies. And I've got a work folder. I think it's capital W. Let me just check. Yes, capital W. Now, I would be very careful on operating systems that don't take into account file system case sensitivity, because the tools do. So if I put a lowercase w, I'd end up with all sorts of problems because it's actually an uppercase W. Now, our IDF target, so I'm using an ESP32-S3, and I'm going to use the USB JTAG to do the actual programming. And that's all we need to do. Now, I've got the board plugged in right now, and it should be this one, but we'll leave it on detect and see if that works. And that's all we need. So now we can create the project. And now let's open the project. So here's our blink sketch. Now, if you're using the Arduino IDE normally, you're probably going to be a bit shocked at all the stuff here, but it's actually a lot simpler than it may look. So if we look in main, you can find our blink example main.c. And if we come into here, what you'll find, if we scroll down, is there is just this app main. Now, with the ESP-IDF, the way you configure things is using the menuconfig command. So if we go back to our ESP-IDF plugin, and if we look down these things here, you can see STK configuration editor, menuconfig. So let's click on that. Now here's all the settings that you don't normally get to play with when you're using the Arduino IDE. But the main thing we want to look at right now is this example configuration. We can see all these settings. So we're not using a LED strip. I have a simple LED on a GPIO pin. So let's have a look at KiCad. So if we look here, GPIO 21 is driving an LED. And now on this board, it's not actually blue, I think it's green because I just put random LEDs on. So let's change this to GPIO. Now our GPIO number is 21, and let's make it flash every half a second, so 500 milliseconds. So we'll save that, and now we can go back to the ESP-IDF plugin, and we can select Build Project and then Flash Device. Now you can also use these icons down here, so this spanner will build the project. So that's built, and then this lightning symbol will flash the project, so Flash Device. And we're going to use JTAG for the flashing because we're connected over USB. And we failed. Oh dear, why did we fail? So let's use the right port, and it didn't work. So I'm going to put my thing into programming mode, so I'm going to hold down reset and boot, and let's try flashing again. And we still failed. Well, this is very annoying. So what I'm going to do is I'm going to change the programming thing to use UART. So we do that by selecting flash method. I'll change to UART, and let's try flashing again. Okay, well that's working fine. So now if I hit the reset button, we should get our thing blinking, and it starts blinking. And of course, we can also monitor the device. So if we monitor, let's have a look. So there's a few interesting things here. First one is our CPU frequency is 160 megahertz. Now we do know that we can go up to 240 megahertz. The other thing that's interesting is this thing here. So SPI flash, it's detected that we have 16 megs of flash, but in our binary header we said we only had 2 megs. So this can all be changed in the SDK config. So let's go in here, and if we go into our SDK config editor, and if we search for CPU, then we should be able to find the CPU frequency. So let's stick that on 240 megahertz. And now let's find the flash size. So if we look for flash, then you can see it defaults to 2 megabytes. We've got 16 megabytes. So if we save that, and then if we build the project and flash again, so that's built, and then we hit flash. And now if we monitor the device, when we boot up, we should see that our CPU speed, if we scroll down, so CPU frequency 240 megahertz. And again, we should see that we have 16 megabytes of flash now. So let's try and find that. Where do we see that printed out? We may not see anything because now it actually matches, so it doesn't need to print out the warning. Oh, there we go. SPI flash size 16 megabytes. Now the other thing is my board has PSRAM, so let's go and find that option and set that up as well. So here we go. Search for PSRAM. So we have SPI RAM. I know it's octal, and that should be all we need. We can also bump up the thing to 80 megahertz, make it faster. So if we save that, and then rebuild, and we'll flash the device again, and monitor, then now when we boot up, if we scroll down, we should see it initializing the PSRAM. So here we go, found 8 megabyte PSRAM device, set the speed to 80 megahertz, the SPI RAM worked okay, test okay, so that's great. We have our 8 megabytes of PSRAM as well, so brilliant. So it is actually really straightforward to doing this, and there's so many options you can configure. So in this menu config, there's all sorts of things you can do. Really interesting to play around with and see what you can do. Now I want to see if I can get this JTAG thing working as well, because you can do debugging, which is really, really cool. So I can see here we have the OpenOCD server, so let's try starting that. And here's the problem. So I think it's already running. So what I'm going to do, I'm going to open up a terminal, and what I'm going to do is search for OCD. Now I think it's this thing here, and I think it's been running from a previous thing. So what I'm going to do is I'm going to kill that. And now, if we open the OCD server and we start it up, then I think that's now working. So what I'm going to do is go back here to the ESP-IDF thing. I'm going to change the flash method, put it back to JTAG. Now let's try hitting flash again and see if that works. So that's much better. Flash successfully. Now what we can do is we can actually debug things. So if I go to the blink example, what we can do is set a breakpoint. So let's try putting a breakpoint here. And now let's try debugging. So we'll go here. I have no idea if this will really work, but let's give it a go. So I think we go here. Somewhere there should be a debug command. Here we go, launch debug. So let's try that. Cool, we've stopped on a breakpoint. It does stop at the start of app main. If we just hit continue, then you can see we come here. Now if we step over this, we should get the log messages coming out. Now if we go to the serial monitor, I'm hoping they might appear. We do start monitoring. Let's see if we step through. Do we get the log messages coming out? We don't. How annoying. Oh, it's picked the wrong port, hasn't it? Let's pick the correct port. There we go. Right then. Now if we step through this, there we go. Turning the LED off. And if we keep stepping through, turn the LED on. So pretty powerful, and obviously you've got all the variables and registers here, pretty interesting stuff. So anyway, hopefully that gives you an idea of how easy it is to get up and running with the ESP-IDF. I mean, the code is pretty simple. If we look at this blink LED thing, it's very similar to the Arduino code. So set the GPIO level, use the blink GPIO, change it to high or low. So very, very simple. So let me know what you think in the comments. ESP-IDF or Arduino? Which do you prefer?